This group of problems, we're going to be talking about consecutive integers. Consider it rained for 3 consecutive days. That means that it rains for, what, 3 days in a row? So the word consecutive means in a row. So when we talk about consecutive integers, we're talking about integers that come in a row, one right after the other. So find the next 2 consecutive integers, for example, 7. So at 5, the next 2 would be 6, and then 7. Negative 7, a little bit harder because we got to go the other direction, but remember getting one bigger would be negative 6, negative 5. Example A, find the next 2 consecutive even integers. So 6, 8, 10, and B, negative 4, negative 2, 0. The next 2 consecutive odd integers, 7, 9, 11, negative 3, negative 1, positive 1. So notice that to get from the first integer up with example 7 to, from 5 to 6, I'm going to add 1. And then to get from 5 to 7, I added 2. So when I come down here for consecutive integers, if I know that the first integer, I'm going to call it x, the second integer would be one bigger, so it's going to be x plus 1. The third integer is going to add one more to that, so x plus another 1 is going to make it be x plus 2. So compare that to the even and odd. Notice that in example 8, to get from the first even number, 6, to the next one, I added 2. And then to get from the first one to the last one, I added 4. But notice that in example 9, in the odd ones, it is exactly the same. 7, I start with 7, and to get to 9, I add 2. I have to add 2 because I'm going to skip over the ones that aren't odd. So for both even or odd numbers, so notice it works for both of them. It's the same. The first integer is x. To get to the next integer, the next even or odd integer, I add 2. And then to get to the one following that, I'm going to add another 2, which is going to make it be x plus 4. So we're going to be using those whenever we're asked to find consecutive integers or consecutive even or odd integers. Example 10, write it as an equation, but don't solve it yet. We're not going to solve. We just want to look at what the equations look like. We've got the sum, so the addition, of 2 consecutive integers. So the first one would be x, plus the next one would be x plus 1, is 93. B, the sum of 3 consecutive even integers. So this time there's going to be 3 of them, and they're going to be even. So the first one's always x. The next one's going to be the next even number, which is x plus 2. And then the next one's going to be x plus 4. So the sum of 3 consecutive even integers is 30 would be my equation. And C, the product, which is what? Multiplication of 2 consecutive odd integers is 99. So the first one is always an x. Since it's a product, we're multiplying, times the second one, and the next odd integer would be x plus 2, and that is 99. So example 11, define a variable, then write and solve an equation to find the numbers for each description. So A, 3 consecutive integers have a sum of 93. So we're going to have the first integer, the second integer, and the third integer. So we'll define all three of those. So the first one's always x, the second one's going to be x plus 1, and the third one's going to be x plus 2. They have a sum of 93, so our equation would be x plus 1 plus x plus 2 equals 93. Combine like terms, so there's 3 x's plus 3 is 93, 3x is 90, so I'm subtracting 3 from both sides, and then divide by 3, and so x is equal to 30. So our first number is 30, our next one 31, and our third one is 32. So you can double check it, make sure those add up to 93. B, four consecutive odd integers have a sum of 56. So we're going to have a first integer, a second integer, a third integer, and a fourth integer. So the first one is always x. The next one, since it's odd, will be x plus 2, then x plus 4, and the one after that, add 2 more, x plus 6. They're going to have a sum of 56, so x plus 2 plus x plus 4 plus x plus 6 equals 56. Add them up, combining terms, that's 1, 2, 3, 4, that's 4 x's, that's 6 and 6, so plus 12 is 56. So 4 x's would be 44. Divide by 4, so x is equal to 11. So 11, add 2, get 13, 15, and 17 are our 4 numbers. C, a little bit different. It says twice the smaller of 2 consecutive odd integers is 7 more than the larger. So this time, since they refer to it in terms of smaller and larger, rather than saying first and second, I'm going to put smaller integer and larger integer. The small one's going to be the x, and because they're consecutive odd integers, the larger one's going to be x plus 2, and they're consecutive, so x and x plus 2. All right, so we've got twice the smaller, so 2 times the small of 2 consecutive odd integers is 7 more than, so 7 plus the larger, so larger. So that's our plan. So let's fill it in. The small one is represented by x, so 2x is equal to 7 plus. The larger one's represented by x plus 2. So simplify, so I'm going to subtract my x, and I get x is equal to 7 plus 2 is 9. So my 2 numbers will be 9 and 11. All right, let's go to a different group of problems. This kind of looks a little confusing here, but these problems are really simpler than that looks. We'll just say that. So I'm just going to just move right along and go on down to example 12, and let's work through it. So for example 12, Sarah already has $45 45 stamps in her collection, and she gets 7 new stamps each month. Write a linear function. So we want to write an equation to represent the number of stamps in Sarah's collection. We're going to define the variables in the function. Now we're going to do this a little bit differently because we're talking in terms of function. And let's let S be equal to the number of stamps that Sarah has. So S is equal to the number of stamps. She gets 7 new stamps each month. Oh, look, that's really a rate, isn't it? Those of you who talked about rates, you can see that, stamps per month. And so if we got stamps per month, we're going to need to be multiplying that by the number of months to change it into stamps. So we'll let M be equal to the number of months. So our equation then would be, Sarah, how many stamps does she have? So the number of stamps that she has, she started off with 45. So we know she's got 45 to begin with. And then she's going to add to it every month. So each month she's going to add 7 more stamps. So month 1, 7, then another 7, then another 7. So she's going to add, depending on how many months it's been, 7 times the number of months that have occurred. So that would be our equation. S is equal to 45 plus 7M. So B, how many stamps will Sarah have after 10 months? Okay, well that means that M is equal to 10. So S, which is the number of stamps, is going to be equal to 45 plus 7 times 10. So 45 plus 70 are 115. So S is the number of stamps, so 115 stamps for that answer. This next one says, how many months will it take for Sarah to have 759 stamps in her collection? So this really right here, how many months, is asking what is M going to be equal to. So that's what we're going to be looking for. So we'll start with our equation again. S is equal to 45 plus 7 times 10. And there we go. So she has 759 stamps. So for stamps, I'm going to put in, that means that S is equal to 759. So 759, oops, I shouldn't have had the 10 here, should I? Copied that. So that really should be an M right there. So S is equal to 45 plus 7M. So now we're going to have 45 plus 7M there. So we want to solve it. So we're going to subtract 45. So that's going to give us 714 is equal to 7M. That's a nice number to divide by 7, isn't it? So divide by 7, and I get 102. What is 102? 102 is equal to M, and M stands for months. So 102 months is the answer to that question. It'll take our 102 months to have 759 stamps. Okay, let's see, next. Example 13, a 1,000-gallon tank. So we start off with 1,000 gallons. It's got that kind of capacity. Initially contains 260 gallons of water. A pump adds water at a rate of 30 gallons per minute. There's that rate thing again, right? Gallons per minute. So that means we're going to need to multiply it by minutes to get gallons for an answer. Write a linear function to represent the number of gallons in the tank. So we'll let G be equal to the number of gallons in the tank, and then we'll let M be equal to the number of minutes that have passed. All right, so the number of gallons in the tank, how many are there? How many are there to begin with? Well, to begin with, we got initially, we have 260 gallons. So that's going to be equal to 260 plus every minute, there's going to be more water pumped in. So every minute, 30 gallons are going to be pumped in. So 30 gallons of 30 times the number of minutes will tell us how many gallons are being added each minute. So that's our equation, 260 plus 30 M. So how long will it take to fill the tank? Well, what does it mean to fill the tank? How many gallons would that be? So how many gallons will that be? Well, it started off, if you look back at the problem, with 1,000. So 1,000 gallons is a full tank, is equal to 260 plus 30 M. Subtract 260, so that gives me 740 is equal to 30 M. So take your 740, divide it by 30, and that will give you, let's see what that gives you. That will give you 74 thirds, which is 24 and 2/3 is equal to M. So if you divide that out and change it to a mixed number. So what is M in this problem? Remember, we wrote it down. M was equal to the number of minutes. So this is 24 and 2/3 minutes until the tank is full. Example 14. For example 14, Brian has a job that pays $10.50 an hour and expects a raise of 30 cents each month. There it is, that rate again, 30 cents per month. Carol has a job that pays $11.20 an hour and expects a raise of 20 cents per month. So write linear functions for Brian's and Carol's pay. So we'll let P be equal to pay. Define the variable in the function. So 20 cents each month. So we're going to need to know how many months. So M is going to be equal to the number of months for this problem. So for Brian, what does Brian start out with? Brian starts out at $10.50. So his pay starts out at $10.50. And then he's going to get 30 cents each month. So plus 30 cents times M. Carol, her pay is going to be equal to, she starts off with $11.20 an hour, a little bit more, but she's only going to get 20 cents a month. So those are their two functions. How many months will it take for Brian to be earning at the same rate as Carol? So at what point, how many months will it take for him to catch up to Carol? So we want to know, when does Brian's pay, when does his pay equal to Carol's pay? That's our question. So Brian's pay is going to be $10.50 plus 30 M, 30 cents times M. Carol's is $11.20 plus 20 cents times M. So we got some extra zeros there. So let's just kind of forget about the zeros. And then let's multiply through everything by 10. So that's going to move our decimal point over, and we're going to get 105 plus 3M is equal to 112 plus 2M. I guess you could have multiplied by 100 and accomplished the same thing. No, been bigger. All right, so simplify. So I'm going to subtract 2M from this side and get M. Subtract 105 from both sides and get 7. What's M in this problem? Well, we wrote it down, the thing. M is equal to the number of months, so 7 months for that answer. And that will do it.